TDM or time division multiplexing. Just assume there are 4 people in a room. Everyone is assigned 15 minutes. You have 60 minutes or 1 hour. Everyone is allowed to speak for 15 minutes. When one is speaking, the other has to be quiet. Time division multiplexing is like this. The time is permanently allocated to different station, and that time only one station will be transmitting, and this goes in the round robin fashion. That is, one time one station will be using all the frequency band to transmit, and next time the second station will send, others will not. So user will take turns in a round robin fashion, each one periodically getting the whole bandwidth, entire spectrum for a certain time interval. So bits from each input stream are taken in a fixed time slot, that is fixed, and output to the aggregate stream. So small intervals of God time, which is analogous to what we have seen in the frequency God band, may be added to accommodate small timing variation, because timing can be an issue. TDM is a widely used technique in telephone and cellular network, digital telephony, data communication, satellite access, cellular radio it is used. Now how it is actually done? See, we have 4 stations. One A means A, B, C, D. Here also you see, this is the colored one. Now multiplexer will combine all these, means it will take 4 and output only 1. Now how does it work? First, the time is allocated to D. So now for a particular time only D will send. Others cannot send, other will not send for a particular time. Once D time slot is over, then C will be given particular time. The same time D has been allocated. So now C will get the whole channel for a particular time. It will send. Now the time will come for B, and then the time will come for A. Again D will come. That is the round robin. Again D will come, then C time allocated, then B allocated, then A allocated. So that is, this is the round robin. The sequence will remain same. The ABCD combination will not be there. Always DCBA, 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 and all DCBA will have equal time, and they will be using the whole channel for that particular time. Statistical TDM. This is asynchronous TDM. Statistical time division multiplexing. So individual streams contribute to the multiplex stream not on a fixed schedule as it was done in TDM, but according to the statistics of their demand. In TDM, if the seat is vacant, no one else can sit, because it is being set or reserved for someone else. Okay? In statistical, or you can say STDM, if someone is asking and the channel is free or the time slot no one else is sending, it will be given the chance. Okay, you can come and send. In traditional TDM, you see here, A, B is sending, but the time slot allocated to C and D, they are not sending. So you can say these are the empty slots. So A and B can send, but in statistical TDM, whenever C and D the time slot will come, A and B will again be assigned. Okay, you can also send, but you can send in A, B your time also, and in the time of C and D also. So basically, it depends all on demand. Say, if B is asking, B will be given the time. C says, oh, I want 3. So it will be given 3 slots. Then B comes, oh, I just want to send. B will be given time. Then A will come, oh, I want to send 2. So it will be given 2 slots. So in statistical TDM, slots are dynamically allocated to improve the bandwidth efficiency, which was not there in the traditional TDM. In the synchronous TDM, this is the actual TDM, some slots are empty because the corresponding line does not have data to send. The station is not sending this. The channel is free. You want efficiency. So in statistical TDM, no slot is left empty as long as there is data to be sent by any input line any input line A, B, C, whichever comes, it will be allocated, because this is the statistics of their demand, not a fixed schedule, not a round robin,